So I'm going to talk about, I'm Jordan Hubbard, and I've done a number of open source projects over the years. And this is certainly one of the more interesting ones, and the latest one I'm involved in, which is essentially a ground up rewrite of FreeNAS. So just to kind of talk about how unusual that is, sorry, let me just jump out of here and switch apps real quick. So FreeNAS, as you see here by Wikipedia, has been around for quite a long time. 2005, I believe, is its official inception date. And it was started by Olivier. I can't really pronounce his last name, so I won't try. He's French. But iXsystems took it on, I guess, a few years after the project was initially founded. And the current UI of the 9 product looks basically like that. That's a screenshot of 9.3, and that 9 branches up to 9.10 now. But the UI is still fundamentally looks the same. So this project has a long pedigree, lots and lots of stuff about it there on Wikipedia that I won't bore you with. But the takeaway is that this is a well-established open source software appliance in the same mold or genre as pfSense and other software projects which have basically taken FreeBSD or one of the other BSDs, or for that matter a Linux, and put all of the sort of creature comforts on top of that. Because obviously you can take an operating system yourself, and I think many of you have done this in your careers, and configure it and install lots of optional software packages and get it tuned up just the way you like it, but that takes a lot of time. And the command and control interface is not likely to be very unified in that scenario, so you're probably going to also write a bunch of shell scripts or Perl scripts or Python scripts or however you roll. And ultimately, over the course of years, kind of get it to where you like it, and your successors either love you or hate you for inheriting it, because it's kind of a one-off. And so projects like FreeNAS really attempt to kind of unify that and create an entire appliance experience around that. So back to FreeNAS 10, what makes it the most interesting for me is that it's one of those rare opportunities you get to rewrite something more or less from scratch. And there were a number of things that were driving that, but we've fundamentally re-architected it. The software is still in beta. Let me make that really clear. And when I do the demo, I'm going to be demoing beta software. So it has known problems with it, and it may even exhibit some of those problems while I'm attempting to demo it. But this is, while it's a work in progress, there's still a lot of stuff that's been accomplished already, and the architecture is essentially something that we feel will take the project forward another 10 years or so, because ultimately hindsight is always 20/20, and when you started your project in 2005, you made decisions back then that were appropriate for the time and for the technologies that were available. But of course, technology marcheth on, and there's a lot of things that you would have liked to have changed if you had the opportunity, and this is our opportunity. So this is a little screenshot. I don't know how visible that is given the contrast in here of what the current UI looks like. So you can see there is a significant difference between that and 9. And again, cleaving to the same goals: open source through and through, extensible, highly configurable and customizable. And FreeNAS 10 is based on FreeBSD 11. OpenZFS is leveraged heavily, just as it has been throughout FreeNAS's history. There's over 430 some odd packages that are installed as part of the default profile. Some of them can be optionally turned on and off, but there is a lot of stuff in there, several million lines of code. In fact, when I went to try and count the number of lines of code in it, I couldn't figure out even how to do that, because there's so much stuff is unpacked and built dynamically during the build time of the system, and then usually thrown away again because there's no need for it after that. I couldn't even tell you how many million lines of code in there, but there are a lot. And everything is organized on GitHub, so we have Like most open source projects, OpenBSD begat OpenSSH, for example. We have also spawned a number of Python modules and little sub-file systems and whatnot, technologies that can be used standalone or as part of FreeNAS. So those are all on GitHub. And we've had to invent quite a number of interesting things, which are also now even used in other projects. So that's something we're pretty proud of. And again, it's all under GitHub, so easy to find. So our key goal was really to make this something that was easy to approach, easy to use, even for a fairly novice user, but not to weld the hood shut. It has to be something that a DevOps person can use in fairly complicated scenarios that we never foresaw. And the more unforeseen the scenarios we see FreeNAS 10 go in, the bigger a victory that will be for us, because that means that it is truly pliable, for lack of a better word. We want to provide the most situational awareness we can about the state of your hardware, the state of the applications running on it, because FreeNAS 10 is a hyper-converged software storage appliance, which is a fancy word for it can do storage, it can also do application hosting and virtual machines. So we need to give you the most information you can get about how that machine is doing at any given time. It's highly asynchronous, so everything is a task that gets spun off to our middleware, which is constantly monitoring the health of things and taking requests and making the appropriate locks and keeping tasks from conflicting with each other. So there's a lot of design and architecture around that. And as I said, to also not just be a storage hosting appliance like FreeNAS 9, but also to jump into the hyperconverged space and do application hosting as well. And part of making this approachable and also powerful is to provide two different interfaces to it. So there's a GUI and a command line interface, sort of along the lines of the Cisco shell or Junos shell with tab completion and help and all that other good stuff, which I'll demo a little bit today as well. By the way, I want to make this an interactive presentation as much as possible, so please don't hesitate to raise your hand or just flat out interrupt me if there's something that I talk about that raises a question in your mind and you want me to elaborate on it or you don't understand it. I'm not a big fan of just boring slideware presentations. So if you do have any questions, please bring them up.
One right here.
Yeah.
So are you booting off of ZFS?
Yes, we are. Everything is ZFS. In fact, UFS is only supported as an import format. We don't use it for anything. So we dynamically load file system modules like NTFS or UFS if we need to bring data off of those things, and then we kick that module out as quickly as possible because we don't want to touch it. So the other thing that I want to emphasize is we're also trying to kind of reboot the open source engagement part of the project. One of the perils of being a primarily corporate-backed open source project, and iXsystems has been the backer of FreeNAS for many, many years, is that people just kind of sit there like baby birds with their beaks open and wait for food rather than actually see themselves as actors in this environment, right? They don't really even see a need to contribute. And that's a fallacy for a lot of reasons. One, no company or organization can do it all. And two, it kind of robs the project as a whole of all the different voices that might have disparate opinions about how to do things. And many times those are good opinions, right? There's a lot to be gained by having dissension and debate and different contributions. It can be painful sometimes if they're really dissenting opinions, but at the same time, it raises the questions. It makes people think a little bit more about their assumptions. So when you have a monoculture, which is just one company, periodically cutting releases, it's not nearly as robust and as healthy as something where there are multiple people contributing. So we really tried to unify everything on GitHub. There's a FreeNAS build project. We wrote our own build system from scratch, which does all of the sub-checkouts and all of the fetching and everything, so basically one make release command and you have an ISO at the end of it and it goes and does all the heavy lifting for you. So we want to make it really easy for people to see how to create their own release of FreeNAS as they're playing with it and experimenting with it and forking it on GitHub, making changes, seeing how those work out, and be able to test those easily. Also, because we've re-architected it, we've made sure that the GUI, the CLI, the middleware can all be developed independently of each other. So you can check out the GUI, for example, on your Mac or your Linux box or whatever, and run gulp and iterate through the JavaScript code, talking to a remote middleware instance, and we've made it very component-based. We're also, obviously, yeah, go ahead.
Will you share the slides later?
Sure, absolutely. We're very aggressive about taking and reviewing pull requests, because obviously if you're deaf to pull requests, people get frustrated and go away very quickly. So we usually jump on those in 24 hours or less. We comment on them where maybe somebody's needs some help or coaching to the process, and if it's a good pull, we take it immediately. And obviously you also have to be responsive to your tickets if you're going to be a successful open source project. So bugs.freenas.org. Again, we have multiple people triaging that stuff every day, responding, interacting with users, and even if they just want to report a bug and they couldn't code their way out of a paper bag, that's perfectly fine. That's an app, and the beta test cycle has actually been really successful beyond even my experience. We have thousands of beta testers. Usually it's hundreds if you're really lucky. We did finally get a count of the beta testers, and we have about 2,400 some odd machines checking in every day, getting updates. So that's great, and something we have to keep feeding. So the things we're trying to make simple for those who may or may not have used FreeNAS before. Obviously, we want to make the storage setup easy. That's one of the most fundamental pillars of FreeNAS. So we have, I call a magical volume setup thing that does a lot of the heavy lifting for you, but gives you some notion of what the ZFS topology is going to look like, and I'll demo that in a minute. We give you all the drive status information, the power management stuff, smart status. We do the drive replacement, so when a drive goes bad and you've got some spares, they jump out of the spares list and automatically replace the failed drive, or you can do that manually. We do all the snapshot management, both scheduled and manual, so you can set up snapshot tasks via a nice little calendar app for weekly snapshots, or you can do them on demand. And then one of the things that's probably the most complicated in any storage appliance is replication. Getting the data on and off the box, backing it up to other brother and sister boxes, sending it up to Amazon, and maybe in the future other backup agents as we look at extending the system outward. So all of that stuff is highly architected. And one of the nice things about our replication versus the 9 replication is the 9 replication uses SSH as the transport, which is great because SSH is really easy to use and it handles all the authentication details and whatnot, but it also imposes performance penalties. And if you want to hook 2 machines back to back over 40 gig or something and do a one-time replication before you send that box off to the Boston office or something, that can be a performance bottleneck. So SSH in 10 is just used to do the negotiation, and then they have a private connection. So we can do no compression, no encryption, or any number of different encryption and compression options that you want. When you are sending it over a WAN, we can do throttling. We can do a number of things that SSH wouldn't let us do as flexibly. So other things, obviously, we try to make simple is the next layer up, which is sharing that data that you just created a ZFS volume for. So NFS v2, v3, v4, Kerberos with or without, SMB2 and 3 with integration and schemas for the various directory services like LDAP and Active Directory. AFP is still alive for backing up your Mac. We support that as well. We've tried to make iSCSI simpler. So if you want to set up an iSCSI volume for a VMware box, you can just enter size, name, and where you want it to go, and it goes and deals with all the LUN and target and complicated mapping. If you do need to get complex, there are the more advanced modes, but we've tried to simplify that, and we even support WebDAV for reasons. We've also tried to make the directory services easier. We've plumbed them all the way down into the operating system layer, so from the command line or from the higher levels, all of the Active Directory, user group mapping, binding, health checks, all of the stuff that you'd expect to be able to do from all these different directory services. I'll talk more about domain controller. We support a local domain controller as well. LDAP, free IPA is kind of a new thing that's new with 10, and NIS for compatibility reasons. We wrote our own service management framework called ServiceD, so it sits in FreeBSD now at a fairly low level, so you can query it. It's got little p-lists. It's kind of ideologically similar to LaunchD on Mac OS or systemd on Linux. And again, it just gives us a nice fine-grained service status information that you really need if you're going to be able to tell if something has fallen over and needs to be restarted, or how much CPU time it's using, how much I/O. We can percolate all our usage stats up from these services now, so we can aggregate those and say, gee, NFS seems to be using 30% of your box's resources in the following categories. Is that bad? Right? You know.
Which component provides the functionality?
Samba. 4.5, I believe we're using now. So Samba is the only game in town right now for SMB. I mean,
Are you going to cover software upgrade? Because I noticed it's not on the list of things you make simple.
Yes, software upgrade is simple. So we have our own cryptographically signed software package update mechanism. We support base packages and delta packages, so we can send binary deltas to give you the shortest possible. That's actually been in 9 for a while, so I didn't mention it just because it's a done deal. And we have update servers that go through a CDN, and so you just basically go to an update UI and you say, are there any new updates available? And it says, yes, these packages have been updated since you last checked in. Do you want to apply them now? Do you want to wait? And if a new update comes along that replaces the previous update, it just moves it out of the way and puts the new update in place. So it's live. It's whatever you want. You can. We have a calendar task that checks every night for more updates and stages them and gets them ready so that you decide when you want to apply them. A lot of the base package updates require a reboot, for example. Each package has a little capabilities list where it says, this is what I require. So if, for example, we just updated Samba and nothing else, it would have a service restart capability with it. So it would say, well, if you're going to apply me, I'm going to have to kick your SMB and restart it. If I gave you another kernel or a bunch of system binaries.
You keep the rest of the system online.
Huh?
You keep the rest of the system online.
We do as much as we can. Again, if we give you a new kernel, you're going to have to reboot, right?
Great.
We don't have live kernel updates yet. But since you raise it, we have also looked at what virtualization allows us to do for maybe future versions where we do have a hot version of the OS and a standby version, and we can swap them. And we can even, through PCI pass-through, punch the hardware out and stick it in another VM. So we're looking at fault tolerance very, very deeply. Depending on how far down that rabbit hole you want to go, it's either simple or not simple. I'll talk about that in just a minute. But yes, we are using Beehive aggressively. We are a FreeBSD-based system, so we're using the FreeBSD technologies. Yes, we are. Yep. So, yada yada, dynamic DNS, rsync FTP, TFTP. We support UPS over USB devices and get status of whether your machine's got power or not. Go ahead.
Regarding the update, is there a rollback mechanism?
That's what you get with boot environments. So every time we apply an update, we create a new BE and we update that BE. And then we reboot you or flip, if we don't require a reboot, into the new boot environment. So where you came from is always preserved. And that can go on for as long as you have available boot disk space. And so as long as your boot pool has capacity, and we have a keep flag that you can set on the boot environments. So you can say, this one's valuable and that one's valuable, but the rest can be garbage collected on demand. So if we detect that boot pool's getting low on space, we start garbage collecting to apply the update.
Are boot environments a FreeBSD feature?
Yes, they are.
Oh, cool.
Yeah. So yeah, if you're not booting your FreeBSD on ZFS, you're really missing out. It's a very cool way to leverage ZFS in terms of booting your root file system. So let's see what else. So virtualization. So we use ZFS very aggressively to support cloning and snapshotting of VMs. Because we do use Beehive, we don't currently have the ability to quiesce the guest memory yet. That's something we have to do a little bit of a refactor on, so you have to stop the VM before you can snapshot it. We would love to be able to do live hot snapshotting, of course, but it's more difficult to do that, so that's on the to-do list. And of course, we do copy on write implicitly. So if you install we have these things called VM templates, which I'll talk a little bit about. And so if you install from any template, it detects that it's the first installation. It creates a data set for it, and then every subsequent installation that is a clone from there. So you can mass provision VMs with very little overhead until, of course, the VMs start to diverge because it is copy on write. So ultimately, you are going to, if they diverge highly, because they all update themselves separately or something, you're going to pay the penalty of the additional divergent blocks. But it tries to make it as cheap as possible. We have serial and graphical consoles. We have our own VNC client built into the web client. And obviously the serial console emulates serial port, so you can do the basic serial console attach and detach from the VM. And as I said, we have a bunch of templates in our collection. The templates are all up on GitHub, so anybody can look at a template, alter it for their favorite distribution of whatever, and send us a pull request, and it will enter the official collection. I think we have something like 18 or 19 different type of operating systems. I'll show you. You have both local and remote storage for your VMs, so you can store them locally on your ZFS volume, or you can go over NFS or iSCSI and put them somewhere else. And that includes the boot. And something that we've had to invent from scratch is the guest tools. So VMware has their VMware guest tools. Beehive has nothing. So we wrote something. And we can get the network configuration, load average, disk allocation. We can execute commands in the VM. That's a work in progress, but we're adding more and more stuff. Just this morning, we added guest copy. So without any authentication, if you have console access, you can copy files to and from the VM, totally bypassing all the authentication mechanisms, which may sound scary, but if you're trying to rescue a VM, it may be the only thing that's possible for you to do. So you can copy a new master.password file or something into place. You can also turn that off. But the guest tools do give us some nice capabilities to do direct host to guest operations. Let's see. Actually, one thing I want to mention is I do mention the Docker slide, sorry, is so we've also used VM to get Docker. So we run a boot to Docker VM behind the scenes. So when you create your first Docker container, it automatically spins up the VM for you, figures out what percentage of system resources to give it based on your overall hardware configuration. You can override that. You can create your own boot to Docker VMs with whatever configuration parameters you want, and it will automatically detect them and use the Docker Remote API to provision the containers transparently onto those VMs. So we also support we proxy all the Docker networking stuff. Again, just this morning, we created a CLI interface to all the Docker networking stuff, so you can create networks, you can attach containers to different networks, move them around between networks, and just do the provisioning very flexibly. So you can create pretty complex networking topologies with containers. And this is actually an area in which the Docker containers are starting to exceed VMs in capability.
To support Docker, are you doing something similar to what Linux is doing, where your system call translating all that stuff?
No, we're running them in a Linux VM.
Oh, you are?
It's all a VM. We're just proxying to a VM. We did look at that, since you raised the point. We could have done native FreeBSD Docker, and there is a project that has kind of made some stabs at that. But you have to be Linux 64 ABI compatible to basically run any conceivable Docker application. You need to do all the network plumbing because the Linux networking capabilities are used directly by Docker, so you'd have to figure out some sort of ePair analog in BSD. It's a lot of work. Oh, yeah. And we looked at that work versus, hey, we could also just create a VM and send the requests over there. And that way we're not chasing the Docker ABI, we're not chasing Linux distributions. As better Linux distributions appear, maybe Rancher OS or something becomes the new hotness, fine, we'll spin up a VM for that as long as it supports Docker Remote, we're in business.
So it's the same thing with Docker for Mac?
Yes, that's exactly what Kitematic and Docker for Mac does. In fact, it uses xHive, which is a fork of Beehive, to go and create a little Linux VM behind the scenes. So we're in good company. Or bad company, depending how you think about it. We also have significantly enhanced 9PFS. We use 9PFS for our local volume host-to-guest interconnect for VMs and containers. And we're pretty much the only people hacking on it right now, and we've done a lot of improvements to it. We have done severe torture tests on it, found and fixed a lot of issues with it, and we're getting about 1 gigabyte per second over 9PFS mounts now. So this completely skunks anything you could do with NFS local loopback. 9PFS is, and we've also just added ACL support, so we do ACL translations for NFS v4 and Windows ACLs. So we've really kind of turned 9PFS into a pretty robust VM to host file system sharing protocol. And it kind of surprised me because I thought at first, it was a science experiment, and one of our guys is really bullish on it. I thought, this should be interesting to see how this goes. But he's done it.
Is that a file system from Plan 9?
Yes. Yeah. So something in Plan 9 survives to this day.
Is that product-based FreeBSD?
No, we've done it. So the lib9pfs project is on the FreeNAS GitHub repo. So it is still agnostic. We can compile it on different operating systems. We haven't made it FreeNAS specific, but we have made a lot of changes to it. We've probably added or changed about 20,000 lines of code. We also have our own curated collection for FreeNAS. So in 9, there's something called plugins, which are actually misnamed. They're really just applications running in jails. They don't extend FreeNAS, which is why plugins was kind of the wrong term to use, but it stuck from a long time ago. And so we've created all those same equivalents in Docker and added a whole bunch more. And we have a Docker images collection on GitHub that people have been contributing to. We probably bring in 2 or 3 Docker containers a week. And when I say curated, I mean both we make sure they work, because there's something like 100,000, 200,000 some odd containers on Docker Hub now, so it's a huge Tower of Babel. So the curation process is actually pretty valuable. Just say, yeah, of the 14 different foobar containers, these 2 seem to work pretty well, and we'll do a little bake-off and see which one works best, and we'll pick it. And if we have to change it because we were wrong, we can swap the pointer in the metadata and use the other one. The other thing that we've done, and I'll demo this in a minute, is we've decorated the Dockerfile syntax with additional metadata so that we can provide GUI front ends for everything. So we can tell which ports, which volumes, which settings should be presented to the user. And we were actually kind of surprised that Docker hadn't already provided this metadata to allow you to construct GUI front ends for containers. As far as we can tell, nobody else has really done it in any official way. So we have the org.freenas namespace, and we can I'll show you that in a minute. We can provide essentially fill in the blanks container creation and management. So, and of course everything's up on Docker Hub and the r/r/freenas collection. So just some quick web resources I put there mostly for those who look at the slides later. There's our GitHub repo. There's our Docker Hub collection. You can fork both of them and point the UI or CLI at your own collection so you can maintain your own set of containers. We have our own collections notion as well, so you can name and save a collection. So you're not stuck with our canned stuff at all. You can absolutely collaborate amongst yourselves and create your own stuff. And you can fork the crap out of these things and play with new concepts and ideas, and the system will flexibly support that. We have a wiki that we're also starting to add user contributed and our own documentation to. And we have the forums, which has a 10 testing section, which is very active, probably 20 posts a day now. So a lot of people discussing stuff. And of course, the usual potpourri of IRC and Reddit things. So let's try a live demo. What could go wrong? So because I'm on a VPN here, I'm talking to a machine at the office. It's of course signed me out of everything. So because it's FreeNAS N, we have machines called Planet 10 and Real Soon and things like that. Those of you who remember the 80s will know the reference. So I'm signing in again. This is fairly slow because I'm going over the Wi-Fi here and a VPN connection to our San Jose office. But here we have the dashboard. I can go in there and I can drag stuff off. I've pretty much selected everything that we currently support anyway. These dashboard widgets are little JavaScript apps, and they're very easy to write. And they also talk to the middleware using a statd protocol, so you can write a widget in probably 30 or 40 lines of JavaScript and say, I subscribe to one of the hundreds of stat sources. So I won't show it to you because it's kind of complex, but there's even a middleware debugger on port 8180. So if you connect to that, you can go to a little stats section and you get a drop-down menu of all 300 some odd stat things, and it'll even bring up a simple graph for you so you can watch them and see, yeah, I'd like a widget for that. And we track just everything you can imagine about the hardware. Drive stats, hardware stats, fan speeds, temperatures, you name it, we collect it. And we can extend that because everything is plugin oriented. The system is largely written in Python. So everything that we want to extend in the system has a little Python module that speaks on, that adds to the RPC collection because everything is an asynchronous RPC call. And so the middleware can be easily extended to add more stuff. So these are just the things that we've done by default. So you have your basic system overview information, disk I/O, network I/O. I can add more interfaces here. There's obviously nothing happening on iX0, kind of a boring interface. I have arc stats, temperatures. There is something happening on EM0. And so let's go to storage. So here is the ubiquitous tank. And I can go to shares and immediately start creating shares, SMB, NFS, AFP, iSCSI, WebDAV, and so on. I can go through the snapshots. I can take a look at them and delete them, change the expiration date, say it should expire after 1 week is the default. I have a drop down. So, trying to make everything really, really discoverable and easy to use. Oh, okay, so that's how I can set up snapshot expiry. No command line foo required. Just go here and click through sort of the obvious buttons. I can look at the topology of the pool. So again, we're a little slow here. So this is all my data drives. I have 1, 2, 3, 4 RAID Z1 ZVols. I have a spare. I have a cache drive or ZIL, and I have a log device. And it's actually reporting some smart status stuff and saying, hi, I'm failing. And that's actually on purpose because we're running test hardware, so we actually plug known bad stuff into our test box to see if it works. I'm also in the middle of replicating a huge collection of media to this box right now, so I have the replication status for that here. So I can see that that's executing, and I'll show you the other box in a minute. So everything you'd expect. These are all the data sets on the box. I go into tank. I can set up a replication straight from here and say I want to replicate it to that peer. Ponies, I'll give it the name whatever. So even the fairly complicated things like sending your data elsewhere using the ZFS send and receive, we've tried to make it as simple as possible. And I'm talking about some fairly high-level concepts here, so if you're lost, raise your hand, but I'm also trying to go through this reasonably quickly. I can also set up replications as first-class objects so that I can refer to them later. I can get their status, and so on. But we're going to add a little replications UI shortly that will give you bytes per second, last replication, replication history. So all that stuff's available in the CLI. It just hasn't made it to the GUI yet because this is a beta. So accounts are pretty much what you'd expect. Slow connection. Come on, come on. Let's see here. I wonder if I've timed out. Let's take a look at Planet 10 to see if that machine is responding to us. No, okay, it looks like my connection's up. I don't know what's wrong here. Well, that's that. There, accounts. Accounts are being cranky for me for some reason. Let's take a look at accounts on this box. Okay, well, I'm not sure what's happening there, but anyway, users, user creation form, what you'd expect, right? Finds the next available UID, username, password, confirmation. I can do the additional groups thing. So, I'm not going to bore you with every little minute detail, but I mentioned directory services. There's the configuration for it. So pretty much everything is fill in the blanks. Click save. It will submit a task. That thing will start happening so I can go immediately elsewhere and do something else. I don't have to wait for anything to complete. And I can see here that I have two interfaces on this box. One of them is a 1 gig interface, which is up, and one is a 10 gig interface, which is down. So I can click on that 10 gig interface and see, what's going on with it? Well, I'm not sure what's going on with it. It looks like somebody has probably unplugged it. So that's the configuration information. So I've got some diagnostic work to do there. Oh, looks like that finally responded to its request. Again, these boxes are a little unhealthy. We've deliberately created unhealthy boxes in our lab because we want to see how they respond when you put bad drives in them. So that's probably what was happening, is it was going through that bad log drive and spending a little time. System information, overview. Again, this box is being a little cranky, but there we go. So this gives me sort of the high level stuff, how many volumes are on the box, how many data sets, and so on. And you get pretty much everything you'd expect with the preferences, host name, where to put the system data set. So someone asked earlier about the boot volume stuff. And there's actually a bug in this where the capacity and space used aren't being displayed right now. That's a known bug that's being worked on. But these are the boot environments. So that's that keep flag I mentioned before. So I can toggle these on and off. And it immediately starts to set that. It sends a little task. So now that's on. I can flick it back off. Again, submits a task. So that's what is going to tell it whether it can garbage collect these things or not. I can also do mass operations on them, like click that flag there, and then click delete, which I'm not going to do. And that's our current active one. So with every update, you get another boot environment created, and you see it here in this list. And if I want to go and give it a more descriptive name, I can click on that too and give it a name and click save, right? So let's bail out of that. There's the update UI. There probably shouldn't be any updates available because this box just got updated today. Let's see, let's go look on Planet 10. That is a little bit older, so there probably are some updates available on that box. No, let's see, so I can check for an update, and now it's going to go off to our update server and do a little cryptographic exchange with it and try and check for and download an update. So that'll happen asynchronously in the background. But let's get to the more interesting stuff. So again, we have flexible alerts. We have alert filters, so you can create them with all sorts of little predicate calculus to say if this kind of thing happens, this is a hardware device goes bad, or my ARC gets to this percentage of utilization or whatever, send an alert to the following email source. In the future, we'll support SMS and other event delivery types. Again, the alert system is highly customizable and pluggable. I can actually go to the now this is actually the TTY, the direct hardwired console settings. I wonder if this replication is making the machine cranky because it is receiving a lot of data. Let's go to a different box. Let's go over here. So layout, language, and region. You get the date and time formats, everything you expect. But again, so here's the service stuff. So here's that, I get little green lights when the service is on. Those are turned off, so they're gray. If there was a problem with that service, I'd get a red light, and then I could click on it and look for more information. I see right now it's stopped, but if it was failing, I'd get more information about what the failure was. And we've used other calendaring applications to kind of give us some situational awareness about what's going on in the box. So it's pretty hard to read that, but there's a nightly update check there. There's the time update. The syslog is being rolled over. So that's my monthly schedule. This is my weekly schedule. This is my daily schedule, and I see the little agenda down here. And where this really helps you as an administrator is to be able to say, well, I'd like to schedule a scrub of my pool once a week, for example. But what's a good time? If I put it right in the middle of the update check, the two are going to fight for I/O because a scrub is a fairly invasive thing to do. So we're giving you the little calendar UI. It gives you a nice notion of what's going on in your box. And other things can create tasks as well to say, I think we should do this periodically, so I'm going to create a task for you. The replications show up as well. If you create a replication task with an interval, then boom, it becomes a calendar task or a calendar object. Yeah?
Are the events fault tolerant? Are they replicated as well?
What do you mean by the event?
If you have an alert, I assume you have some database component that's storing
Yes.
all the events.
Yes.
And if that should fail, you lose all that history?
So you have a system data set which is where we put log information, certain databases and whatnot, and you're expected to put that on a pool with some resiliency. At the end of the day, now you can replicate that pool. So absolutely, if you want to then replicate it to another server somewhere else and say, I want to keep copies of this, maybe I've got one big honkin' file server someplace and I have a bunch of little satellite boxes and they're all replicating their system data set or their log data set to that box, absolutely you can do that. And you can bring it back in a disaster recovery scenario. But at the end of the day, you have to be able to put your alert data and whatnot on some sort of persistent storage. So the assumption / hope is that you're gonna do the right thing in terms of the ZFS stuff. So I actually skipped over that because that box was being a little cranky, but let's give it a shot. Let me show you what the creation looks like. Yeah. Maybe picking this box as my demo box was not it wasn't acting this cranky before, but I didn't start a replication stream on it before leaving either. Let's see here. I really want this box though because it's got disks. Actually, I have another box with some disks. Let me go over here. All right, storage. Okay, VPN, don't fail me now. All right, so create, and these are the drives I have available. And so I can say foo, and I can either drag this little triangle here in the different quadrants, and it's going to create the topology for me. So, and I'm going to get a notion of how much parity and how much data I have. So these are sort of guesstimates because ZFS has to do some tricky algorithms to try and stripe your data. Well, stripe is the wrong word, but to distribute your data across the pool. But when it comes time to create your system data set, you're going to try and set it with whatever the appropriate level of redundancy is. So if I click that as a RAID Z, any 3 of the drives in that particular VDEV could die, and I would still be able to recover from that. Or I could say, you know what, I want maximum speed, and that's going to put it into essentially an array of mirrors. So this is what you would tend to use for VMware, for example, where you want good redundancy. I can lose any one of the drives in any one of these mirror groups, but I want maximum speed, and the way ZFS works is that's maximum speed. I can also just select a profile. So if I say virtualization, it's going to pick the same thing. If I say, well, I want a better mix of sort of media, and for some reason that, demo gods, don't fail me now. Let's try one of the other ones. It looks like it crashed. Yes, all right, I crashed it. Anyway, typically, that's going to pick a nice default profile for you. And again, this is demo software, but so it kind of picks parts of these on these quadrants in this triangle. And I don't know who broke the drop-down menu because that's been working for months, but somebody did. Bad engineer, no donut. We've made the peering UI, let's use this machine, as simple as we can. So if I want to create a peer, I go to here, I can say this is going to be an SSH peer, which means it doesn't assume much about what's on the other side. So it can actually just dump the data into a file, because ZFS send is essentially just a stream of bytes. So if you want to just dump it as a blob, you can totally do that. I can send it to, I can set up a VMware peer, which I use for doing VMware snapshots. So I tell the VMware box, hey, I'm taking a snapshot of your volume, so I want you to snapshot all the VMs within that volume. And VMware snapshot type is one of the snapshot things that you can create. Or I can create an S3 peer for sending S3 backups. But if I set a FreeNAS peer, it's going to give me the highest level interface it can because it can make assumptions. That's just the port, and in fact, that should not even be there. There's a ticket to remove the port because it's an implementation detail. And I give it the username, and again, this should be filled in with a default, but 10 seconds is a reasonable health check interval, and it will create a peer entry. So it's going over to that box and saying, hey, this guy wants to peer with you. And he creates a peer entry on the other side. So if I actually...
Is this a physical box you're talking about?
Yeah, these are physical machines.
You basically have an existing machine, and you're announcing to this machine that it's peer.
Yeah. And then you can do higher level things with that relationship, like replicate and send data very easily to it, because now you have that side channel where you can, so if I go over to Ponies and I look at its peers list, we see automatically real soon has appeared there. So now they know about each other. And the health check, and so it says, yeah, online, here's the round trip time to that peer, so there's little peer health checks. So, you know, I could go on and on, but you know, there's a lot of stuff in here, and we're really trying to make it possible for you to set up file servers, replicate the file servers to other file servers, have high-level relationships with them, get lots of real-time status information. And with that, let me go to the scariest part of this demo, and I'm just going to create a VM live. Yeah.
Behind the dashboard, is there like a REST API? Or
Yes, there is. So this entire UI uses a WebSocket API, and you know, again, since you asked, if I go to that same machine, I'm talking to the WebSocket debugger. So there's, it's also talking, so same credentials. So remember I told you that, you know, you could look at stats, for example. I can flick this down, and these are all the data sources.
this is the WebSockets, not REST.
This is WebSockets, and we create a REST API automatically based on the WebSocket metadata. So the two stay in sync all the time because REST is basically just another mode. So I can say, you know, okay, for let's pick an interesting stat there. I don't know, yeah, like a disk 0 octets read, and I can say load. And actually, that one is sending floating point values, and the debugger dude is not dealing with floating point properly right now. So I know that's not going to work, but it will be fixed. There you go, interface stats. So I can look at, you know, packets per second. It should give me, unless the demo gods hate me today. No, they hate me. I host a debugger. So I can go into this thing and I can look at the events that are flowing across the WebSocket. So everything in this system is JSON. So we just send JSON blobs back and forth.
Is there any like language bindings for the API?
Yes, Python. So we support Python. There's a Python RPC, and there's also a JavaScript RPC bindings.
Not that it makes any sense. You have a SNMP agent and a MIB that corresponds,
We do. It's one of the services.
and people actually use third-party management.
They do. We would have probably liked to have dropped SNMP at some point, but nobody is going to let us do that. So yeah, under management, there's SNMP. And so if I go to SNM3v3 support, there's a community string and the password authentication and all that goop. And yes, there is a MIB. And we're trying to be as interoperable as possible. Yes, Sean?
Bookmarks for sending streams. Are you guys using bookmarks for the stem send yet?
You know, it's interesting because I just saw some commits fly past that had the bookmark in the commit line, and because I get hundreds of those messages a day, but I know that's definitely the plan, is to use bookmarks so that you can retire the snapshot. If we don't use it already. We may use it already, actually. So let's, for some reason this machine is being cranky. I'm gonna reload its session. We call this goat sacrifice. Usually you clear the cache and you sacrifice a goat. It was working earlier, so I'm not sure why it's being cranky with me. All right, let's go to VMs. Hope that it comes up.
Sure, we got a question back there.
Yeah, there you go.
I was wondering, you mentioned a RESTful API, so is it possible to do everything in UI through an API?
Yes. Everything you see here can be done programmatically. So maybe on that, before I go create my little Windows VM, just as a look, I can do this demo. Let's invoke the CLI. So the command, so both the web UI and the CLI use the same WebSocket interface. And hypothetically, you could write a Python script that used the REST interface because, again, the REST interface is just a wrapper around the WebSocket stuff. So there's our little cow. And so, you know, if I say something like this, show here, it's sending an RPC to that box and saying, show me all your disks. And the text formatting is all part of the, again, it's getting JSON back, so it's formatting it into an ASCII form. But if I said set opt output format is JSON, and I redid that query, I'd get JSON back. So that kind of gives you some notion of that, yeah, this is essentially all API calls. This is all RPC.
You have a JSON query when you have a CLI?
Yeah, yeah. So, sorry, setup format is ASCII, because that's easier for humans to understand. So yeah, I can, for example, let's create a Docker container. So tab, container, create, name equals Plex, image is FreeNAS/Plex, and I can tab complete that too. But I don't have that image loaded in my cache, so it tab completed to the Plex media server, and I'm not going to use that one for this demo. Hostname is Plex, and now let's hit tab here. Now it's going to tab complete based on that Docker metadata. So I can say volume colon, and let's see. Oh, actually, I think I have to pull that image first. Name equals FreeNAS. Okay. So you see it's asynchronous. So it said I created that task. If I say wait, it's going to say, OK, I'm downloading the various layers. And but I don't have to wait. I could sign out of the CLI, and it would just be doing that off on its own. So now it's going to go grab that image from Docker Hub. It's grabbing it right now. As you know, Docker containers have lots and lots of layers based on many, many things. So it's not instantaneous the first time, but we keep an image cache. So for the frequently used images that you do have, don't require that every time. So, but I wanted to make it clear that, again, that everything here is an API call in essence. So let's go back over here to the VMs, and let's create a Windows VM. And we can see here in the taskbar, I'm pulling that image. So we always know what's going on, whether it's on another session. And we even have session calls so we can write to other users. We can send them little chat messages. So let's create a Windows VM. These are the templates that we have built in. These are in the Docker, the VM templates project on GitHub. So there's the boot to Docker one we use. We have Arch Linux, CentOS, Debian, Fedora, various versions of FreeBSD. We have FreeNAS itself, the 9.10 FreeNAS, and the 10 beta 2 image. These are frozen templates, essentially. They're fully installed, ready to go. Linux Mint, NetBSD, OpenSUSE, pfSense, SmartOS, Solaris, TrueOS, and various Ubuntus, and the Xential VM, which we use to provide the local domain controller and Exchange compatible email. So we actually use the VMs to also create proxied services. So if you actually go into services and say, I would like to be a Windows domain controller, please, it will quietly behind the scenes install that Xential VM for you, and then get the host settings and whatnot and present it in the services UI. So you just think you have a service running that's providing a Windows Active Directory domain controller, but it's really a VM. But anyway, we're not going to use a template. We're going to create one ourselves. So let's say we want to put it on tank. We want to use the UEFI bootloader. And I'm not going to give it a device yet for reasons that will become evident. Windows demo. Let's give it 1 core, 2 gigs of memory, because it's Windows. And then I go to devices and I say, all right, I'd like a new CD. Because I'm old school, I'll call it CD0. And then I go to my tank ISOs, and there is a little Windows ISO that I pre-uploaded there. So save. Now I'll create a disk device. I'll call it DK0 because I have digital DNA in my blood. I'll give it no target path, and it'll automatically put it in tank VMs for me, so I don't have to worry about that. And I'll give it 10 gigs, and I'll say it's going to be AHCI. I could create a VirtIO disk, or I could create an AHCI disk, but Windows likes AHCI. Save. OK, let's give it a frame buffer. 1024 by 768, sure. I can give it its own VNC port. I can enable VNC, but let's not complicate our lives. Let's just do that. And let's give it a network interface card. Call it EN0. It's bridged by default to my default Ethernet interface. I could select it from here. I could put it on EIX0. I could NAT it. Because it's Windows, it doesn't support VirtIO out of the box, so I want it to pretend to be an E1000. I could give it its own MAC address. Sure, let's NAT it. Why not? Or we could bridge it. Actually, let's bridge it. That's more interesting. So that it's going to get its own IP address. It's going to DHCP. Go ahead.
Could you go back?
Sure. You want to look at this device?
Yeah, you had bridge interface default, but then you had mode bridge. I guess I'm confused.
Oh, because if I bridge, I have to give it another interface. I have to give it a specific interface, I'll NAT through that interface. Maybe bridge interface is a bit of a misnomer. That's a reasonable point. We should probably change it from bridge interface to physical interface or something. And finally, I'll give it a tablet, a USB tablet. And what that does is it lets me get XY coordinates on the graphical console rather than delta mouse movement coordinates, so I don't get out of sync with the mouse cursor while I'm moving it around. So we have a CD, we have a disk, we have a frame buffer, we have an Ethernet device, and we have a tablet. And now I can select the boot device. Actually, I don't need to because it's going to do that automatically. I'll save it. And it's creating that VM. And while it's doing that, let's just tab over quickly to that. OK, there we go. So that was our Docker container is also ready to go, or Docker image. So Docker, I could do this via the GUI as well, but we're showing off the CLI. So Docker container create, and at any point I can hit tab to see what my various, and I can type help. Gives me all kinds of different types of how I'd create different types of containers. So I have examples. Name equals Plex, image equals, and now I can hit tab completion and say FreeNAS/Plex. And I can say, and now because it's got the image and the metadata, it's giving me all this tab completion stuff. So these are all the port values that it knows about that are important to that specific type of container. So I'm going to say, all right, I'm going to select the defaults for pretty much everything. I will give it a host name of foo, and I'm going to put the config data on mount tank containers plex config, just because I happen to know that's the path, but I could open another window and look. And I'll put the data on mount tank containers plex library. I believe those are what I used. Now I'm paranoid. So let's log into the box and look. It doesn't know to tab complete into the host namespace because it doesn't know where it is in that string. That's a little too rocket sciencey. But it can complete all the data. So yes, I was correct. All right. Boom. Again, it's submitted. I can do a task show. It shows me all the things that it's currently doing. So here's that replication stream I was talking about. 72% done. 18 megs per second is the average speed. It's receiving it into that data set. If I wanted to get more information about a specific task, I can look at the ID and say task 179 show. And then I have a little bit more. I can even do a query, which gives me all kinds of propeller heading information about that task. So, and there's the various things that we've gotten from it. But if I type just pending, it shows that's 90% complete. So again, I can just type wait. Oh, well, it just finished. And now I can say Docker container, and now it shows up in the tab completion, Plex start. And our Windows is created in the meantime, but if I go over to Docker containers, there's my Plex. It's got a green light. Boom. And let's look at its web UI. There you go.
What did you
So
just click on?
I clicked on the web UI button for it.
Oh, yeah, actually, and a button.
Yeah, right there. So I can do a console, which because Plex is a non-interactive container in Docker parlance, it'll just fork a shell into that thing, and I can use it to debug it and poke at it. So you can do that right here. So in a second, I should get it an interactive shell. in all scriptable Docker. So I see the Plex media server running there, right, and so on. And then and that's the web UI, and that's one of the Docker properties that we added, the org.freenas.web UI. We have a little string substitution thing where we can say, it's got a web UI and it's on this port. And so, boom, you just get the web UI for it. Kitematic does something similar if you click on that right button. So let's go to our VM. So, and again, we can see all the stuff here. So if I do this stuff, the creation manually, there's my collection. Remember I said you had collections? I can go create one. So I can name my own collection, which is a path on Docker Hub, or I can use the built-in one. So if I say container create FreeNAS, it's going to go fetch the container list from Docker Hub, and now I've got, these are the canned containers. So if I go to BT sync, for example, and I click on that, and I say BT, and the Docker host is the default one, but if I had multiple VMs, I could click on the one I wanted to host it on. I can look at the documentation for it if there's any. This has the generic docs, so there's really nothing to show about that. That's just our bad. We have to fill that in. And there's that UI I mentioned that's all created dynamically. So I can now say, all right, it has a /config directory, so I can click on that, and I can start browsing through my data store and give it a directory there, and then save it. So going back to the VM, though. So Windows, that's our new Windows VM. Yeah, everything is set up, I think, properly. Let's start it. It'll take a minute. And VGA console. Oh, click a key. Sometimes it's hard to get in there in time. That's fine. Now I can click a button. And there we go. There's Windows. And it's going to run me through the standard Windows installer. It's going to ask me for my virtual disk. And once I have that thing fully installed, I'll probably install the VirtIO drivers on it so that I can get high-speed VirtIO networking, and I'll change the NIC type to VirtIO, and boom, I have myself a little Windows desktop. And of course, I can install RDP on the sucker so that I can RDP to it with my RDP client and so on. So I think, last but not least, we do have a little wizard which will take you through the installation step by step, starting with all of your localization preferences and whatnot, and take you through the pool creation and so on. So that's pretty much the system in a nutshell. And it's, again, it's in beta, so it's still evolving, but we've tried to think of every possible storage and application hosting scenario that you might want to do and make it both easy and using the CLI as powerful as we can as well. And just to note one last thing here, this is a little scripting language. So the CLI has its own language. So we have the classic Worms game written in CLI script. So there you go. It's ASCII only, but you have functions, you have loops, you have conditionals, you have all the various things. And I've taken advantage of that to write tests. So I have torture tests written in CLI script. And so I can absolutely thrash the crap out of my box by creating hundreds of accounts, volumes, data sets, snapshots, creating peers, destroying peers. And now that we have the guest tools, which actually I think I can kind of show you, they've just been entering the UI. So, oops, no, wrong screen. If I start this Arch VM up, Windows doesn't have the guest tools yet. That is an open source project, and it does compile under Visual Studio, so I could install it there. But once I start this guy up and he finally makes contact with the tools, I can, oops, sorry. There you go. I can get information from the guest. So that's his load average and the interface, and because he hasn't been set up yet, he has no IPv4 address, but he has an IPv6 address. And I could use the console also from the CLI. So if I go to /VM arch1, I think it was, no, what's it called? Tab complete. Come on. Arch2, or just Arch. I can say show. OK, that's running. Console. There you go. So I'm spend a lot of time showing off the CLI too, because I assume that would appeal to the system admin DevOps types. Because a web UI isn't, everyone's cup of tea. It does try to make it very pointy clicky, but if you want to script this stuff, and as I said, we've just also entered the guest tool space, so I can now, I can ls file, oh, I have to give it an argument because that doesn't work yet. I can get JSON data back from the guest, so I can navigate it. We just added the copy command this morning. We have exec, so I can rescue the guest. Yeah.
Do you have an expect type of thing from CLI to the console?
Actually, we don't need to because we have data types in the CLI. So you can say, return me the results of this thing as an array or a hash, and then I can write for loops which iterate. So when I've really roached my box by creating hundreds of VMs or something, I can write a little for loop that just goes through each one, or I can send it a command and then get the command output back as JSON. So we are interposing the heck out of everything involved in here, and we use the VirtIO socket interface to talk to the guests. So that's how the console is done, for example. It's done over VirtIO sock. So we have a complex relationship with the guest that we can format its data and do any number of things with it. So we really tried to create a comprehensive toolkit here, right? That people can script, they can extend, and hopefully over the next 10-year lifetime of FreeNAS, God willing, everything may end tomorrow, but still, people can contribute to this and write their own plugins and their own services and their own front ends and whatnot, consuming the APIs, and do it in a very high level way that hopefully makes sense and is architecturally clean and comprehensible.
Is the CLI documented yet? Or is it still
Yeah.
in progress?
Well, the documentation is always a work in progress, Ron. But if I do go to any of my machines here and I say CLI, it will connect me to the built-in documentation reader, so I can walk through the command space. Yeah, quite a few commands in there.
What's the ETA for that? What's this estimate delivery for the
For the release version, well, we've made some schedule adjustments recently, but we hope end of February, early March is an aggressive estimate. As the number of beta users ramp up, and they have been ramping up a lot, they keep using it, and they keep finding bugs, and they keep reporting bugs, and we have to keep going back and fixing bugs. And then when they're not reporting bugs, we also break things ourselves, because we're still adding things like the guest interface stuff, and we're actually in the middle of doing, since we've now finished the heavy lifting in the UI, we're looking at how to pretty up some of the stuff and use the table interface a bit better. And we've gotten a lot of early feedback from users which are suggesting, yeah, that's really nice, but what would be better is if like for example, just to give you an example of what I mean, looking in storage and data sets, and there's some obviously performance, right? First make it work, then make it work fast. So we have performance work that we definitely want to do, but looking in here, this is kind of clunky. Right, so we're looking at little view modifiers where you can say, you don't have to look at it this way, you can also look at it as a table. And then if you can look at it as a table, you can do mass operations and stuff, and you can do searches, and I want to delete all or select all data sets that start with the word foo, and then I want to delete the selected data sets and so on. So that's something we want to add. Yeah.
You spoke a little bit about performance. How does this operate on sort of lower power boxes? Is there a CPU limitation for when you're setting up a number of VMs? Is you torturing it? Is there gremlins that try to hit first? I mean, obviously, it hits the storage pretty heavily.
Right. I mean, honestly, ZFS is the biggest pig in the room, just in terms of how it likes to use ARC, and it's trying to achieve performance goals by aggressive caching. Sure, if you create 1,000 VMs on your Intel Atom box, you're probably going to hit some bottlenecks. But especially if you get them all 8 cores each or something. But Beehive is actually pretty lightweight. It's reasonably good at not buzz looping or doing anything silly when you sort of over provision things. And again, because of the way we're using ZFS for the disk provisioning side, if you're creating 100 CentOS boxes, they're going to all inherit from each other, and until they all diverge radically, they're going to be using a lot of the same disk blocks. So how long is a piece of string, right? I can't really answer your question in a specific sense without knowing the hardware configuration.
I
But
always think of things like Synology or those sort of more integrated devices.
so
Sort of drop in place.
so that the smallest possible Synology, I think, is a 2-drive box, a little plastic case running an ARM processor. I don't know how many.
But that's sort of low power device.
Yeah, it is. This doesn't run on ARM, so you're already going to be, constrained to what Intel or AMD can deliver for you. CPU hasn't been really the bottleneck in terms of power. The drives. So if you unless you're going for an all SSD rig, which do it if you can, you're going to want to set the smart parameters fairly aggressively to let them spin down and idle out, because keeping things spinning takes probably more power than most things. Power is a difficult one because it's usually not where you think it is. One of the number one power consumers on this thing, what would you say it is, just offhand? Well, it's the screen. And it's all flash inside, so nothing to keep rotating there. Memory, CPU, it's all Intel CPUs are bouncing off the rev limiter pretty much like this the entire time, just to fit within their thermal envelopes. So unless you're really pegging it consistently, and even then it's going to back off on you. It doesn't want to be there, right? They're basically over-speccing the CPUs in terms of the thermals. So you have that as well. Sure. Red shirt?
So, in a room full of smart people, and you say, don't ask on the board, you just threw down the gauntlet. So what's the UPS problem?
Oh, no, it's not a problem. They're just annoying to support because there's like 32 different models, and there's this long, here, I'll show you the UI for it. It's a pain in the ass. Here, services, oh, somebody broke it. Management, UPS, okay, and then you have to go through this driver list.
Just one or two.
Yeah, just a couple. You see yours yet? Did it go by? They're a black art. The assuming you don't have too many USB peripherals either, obviously you have to find out which of many possible USB ports it's plugged into, and you're not going to get a lot of guidance because they have cryptic names, but this is the annoying part. And everybody with a UPS seems to have one that's not on that list, or it is on that list, but it's acting very strange. So it's just a pain in the ass to support them. If the UPS industry needed anything other than a kick up the backside, it would be some standardization, but they're not interested in that.
I always talk to UPSs over SNMP, and if the UPS manufacturer doesn't support SNMP, that UPS manufacturer goes out of my data center.
Sure, that's not the problem though. People are hooking the box directly to the UPS via the USB cable, and they're expecting, but they do it all the time. And they want to do that because they want the UPS to tell the box when it should do something like start shutting down or whatever. And it's
Remember, the target market for FreeNAS is not necessarily someone who's going to have a UPS with a network port on it.
right. There's a lot of home users, that sort of Synology scenario again, right? If you're keeping your family photos on this thing, you've never really been in trouble until you've endangered your wife's wedding photos. So. What's that?
I said, why do you care on ZFS? Just let the box shut off. You lose up to 5 seconds of data or whatever the transaction.
People are surprisingly paranoid about this. I have my stuff on the UPS. I live up in the mountains, right?
Customer requirements.
Yeah. Yeah, exactly. Don't ask questions, man. They want it and they demand it, and it's there. And you can configure the wazoo out of it and have it send you alerts and stuff.
Benefits of having expunged UFS.
Yeah. It's got journaling now, Matt. Sorry, there's one guy back there that had a question first.
As far as the ZFS exposure, can you go in and tune the crap out of it if you want? Put your cache on nice fast flash, all that kind of stuff.
Absolutely. You can do it draggy-droppy in the GUI, or you can do it in the CLI, and you can also create different topologies for for cache and ZIL devices, and have mirrored ZILs, or whatever rocks your socks. Also, we haven't done it, put it into the UI yet, but you can also mirror your boot volume. So in the next version, there's going to be a little topology button, so I can also mirror my boot device. You can already do that via the CLI, but just not in the GUI. So that's one of the things we want to add, is the attach-detach disk interface in the GUI. Because people like to use crappy USB drives, and if you're going to do that, and not a SATA DOM or a small SSD or something a little bit better, you can at least mirror it.
So let's say I hand configured one of these how I want, and now I want to make a second one that's substantially similar. What's your recommended way of doing that?
Save the database, do a new install, and import the database. So everything's stored into a MongoDB database. All the configuration information is unified, and snapshotted and backed up and whatnot. Sorry, I think somebody here was first. Yeah.
It's more of an academic question. So you've got ZFS as a copy on writing transactional file system, on which you're running butter apples on a file-on-file system, which is also transactional. What kind of fun have you had with those transactional file systems?
You forgot iSCSI. You're supposed to do this all on top of iSCSI LUNs, which come from a remote box. I mean, come on, man. If you're going to get creative, you might as well go for the brass ring.
I'm just confident you found fun pathologies there. I want to go there.
Yeah, I mean, at the end of the day, ZFS gives you zvols, which are block devices that are really just data sets, and so you can have inception up the wazoo and format those however you want. And with iSCSI, you can export, or NFS for that matter, because we support that already for the data stores. You can take a file and make it a file system. You have to know kind of what you're doing. Well, yes, you get lousy performance, and one of our favorite scenarios is somebody sets up a ZFS pool on top of a bunch of iSCSI LUNs, and they set it for RAID Z3. Because you want to send lots of duplicates of that data over your network connection just in case one of those LUNs should go bad. They don't really know what they're doing, right? They pick the topology, and ZFS doesn't know or care. It sees a virtual device. It's like, okay. In fact, if you want to really have fun, we support simulator mode, so you can simulate disks and create a little pool and then create a whole bunch of files on that pool and present those again as disks again. And we do that for testing purposes. So yeah, you can really kill yourself in style. There was someone in the back from Microsoft?
Yeah, so it's more of a curiosity enthusiast question. When you did the Plex demo real quick in Docker,
Yeah.
And you just quickly showed you clicking around in the GUI, you had a bunch of content already loaded in there. Was that something that it pulled as part of the image, or did it actually mount the volume as part of your
Yeah, it mounted the volume. That was that /mount tank containers Plex library.
Okay, you specify the library already, and then it was able to import that into Docker.
Yep.
You didn't have to attach a Docker file with that? Or you just use the Docker file for
The attached Docker volume was part of that creation.
Okay.
So when you create a container, because containers are immutable, this is something that really hoses people when they don't realize this. Containers are meant to essentially be, fungible. You can throw them away again because the data lives somewhere else. So when you create your immutable Docker container, you say a config should be over there, and the library should be over there, and the /foo should be there, and the /bar should be over there. And the container is the one that says, I've got these volume requirements. Now, you raise a good tangential point. For example, the Plex container has a /transcode directory that's marked optional. And I didn't specify that. And so in that case, it actually goes into the boot to Docker VM. So it just creates a little temporary path and says, here.
And how's the performance on that from a transcoding perspective in a Docker container?
It's using 9PFS to talk to, it has a memory file system for some portions of its files, so it's talking straight to memory. And for the remote file system stuff from the VM, it's using 9PFS, so a gig per second. So actually very reasonable.
Oh, wow. Okay.
Yeah. Yeah, when I said we haven't emphasized performance yet, I kind of lied. We have done some stuff to try and get the maximum, because we know you guys are insane and you're going to create thousands of containers and stuff on your boxes. So, my CLI scripts do those scenarios, and I have hosed many boxes in the making of this video.
Your service D gone upstream to FreeBSD guys?
Yeah, it's kind of a political battle. I'm not. I already did the whole LaunchD battle once, and I have the teeth marks to prove it on my leg. So, I don't want to get into a whole political battle. We wrote just enough of a launchd clone to serve our purposes. So you could also ask, is it really, enough to satisfy the generic FreeBSD user? I mean, it's got some nice things. If of course I went to sleep, so it logged me out of the network. And now my VPN, it's going to have to come back up. Anyway, I could show you the service cuddle and stuff, and it shows you the nested hierarchy of the processes. So from a kind of a shiny object perspective, I would hope at some point somebody might come asking, hey, you could replace etcrc with this. Yes, you could. I happen to have an existence proof that we did. But I don't want to get into a political, you can have my shell scripts when you pry them for my cold dead fingers kind of discussion either. Because there are plenty of those folks as well. And they like the visibility. And to be honest, this is kind of one of my favorite topics because I was the engineering manager at Apple for launchd. When you do genuine socket activation-based daemon launching, e.g. you're proxying on the socket that the daemon wants to be talked to on, then you really have something. Because you basically just come up and say, nothing's running until it needs to run, and it can need to run at any time in the system's life cycle, and that thing will be started automatically. Serviced doesn't do socket activation yet, so I wouldn't sell it heavily just based on that shortcoming alone. But file descriptor passing is the way to go, and proxying and socket activation is the way to go. It's just a pain that Unix domain sockets suck so hard. Anything else? Any last questions? Okay, thank you.